Hello?
Oh, this is Chuck.
Yeah, hi. I mailed my slides. I think we both mailed our slides to BP. I assume he was going to come on and show them, or otherwise we'll just share our screens individually.
Screen sharing works better for me.
Okay, fine.
About the screen sharing, switching who shares the screen actually triggers some bug in, I think it's primarily if you're on the browser version with sometimes the screen sharing doesn't work after you switched it around for some reason.
Yeah, given how long the delay is, the audio delay is, it just is very awkward to ask someone else to run the slides.
I think most of the delay is actually in the time it takes until you see the screen update from that the person switched the. So, but anyway, yes, I know there's a huge pain in that delay. So, you can try. Hopefully, not many will be affected. Yeah, one thing we could try to is that the ones who actually is presenting could actually have their video on, because I don't think we're, if they have enough up-band capacity, etc., because that's makes it a bit easier usually for people to follow along, see the presenter. But that's if you're willing and able.
I can do that.
Okay. Okay, since this is now 1 o'clock, I guess I have to start with the note well and tell everybody that, hey, whatever you say here is an IETF contribution and be aware of that fact. I guess that's about it. That's not 5 minutes. We do have 5 minutes for agenda bashing. Is there anyone who wants to say anything about the agenda?
Yeah, I would like to say something.
All right, if not,
Yes, I would like to say something.
would you?
This
Go
is
ahead.
Chuck. Yeah, and there does seem to be a significant audio delay here. There's one item that's not included on the agenda. I'm not asking to change that right now, but I just wanted to mention that I am working on computational storage and continuing that work, and that does fall in the category of future work items. There hasn't been an urgent need to present that to the working group. It's just sort of an FYI, and there is a personal draft on the data tracker if people are interested in looking at it. That's all.
Have you updated that recently, or intend to do that, or should we just go back and read it?
Go have a look. I'm intending to update it again. There are some ideas that I wanted to put into it. Right now, it's just basically a pile of ideas related to computational storage and NFS, how we might implement it in NFS. So if you're not interested in computational storage, I don't think it's probably going to be very interesting or legible. But yeah, I'm planning to continue to update it.
Okay, good. So I guess first up is now if we're done with the agenda stuff.
Are we
maybe
recording?
First up is Soren.
Are we recording?
I started it, yes.
Okay, is there someone taking minutes?
I don't know.
Don't think I can because I need to focus on presentation. Brian will move before, I don't know. So my first presentation is the Indian. Okay. How do I take control? Can anybody give me control?
I can barely hear you, Soren. You're very muffled.
Can anybody
That's better.
give me the control? Yeah, I was behind my sorry. Can anybody give me control? So how does it work? Oh, I can I take the ball? Let's see.
I think you should be able to, but
I'm trying, but it doesn't want
share your screen.
it doesn't want to let me move.
If David, if you give the ball to Soren.
Yeah, I think that was, yeah.
Whoever has the host role can do it.
Yeah, I cannot. I'm trying, but I cannot. Is there another way to maybe here in the another way?
Yeah, I think Dave Novak needs to do what is colloquially called
Yeah, what do I
toss the
need to do?
ball. Make you need to make Soren a presenter.
Grab the ball in the participant list and drag
Okay,
it
let me
over
see.
to
Where is that?
the participant list.
Or?
So view the participant.
Oh, in the participant list. Okay, yes, all right.
Yeah.
The ball here.
Allow change role to presenter. That should be it.
Okay.
Yep.
Okay.
Yeah, ball jumps. He's got the ball now.
Perfect. Perfect. Okay, and I'm going to right. Okay, So I put together a set of slides based on a draft.
Slides aren't coming up yet. Have you got them shared, Soren?
Okay, wait a second. How do I do this? Share it should be in the here, right? Oh, yeah. Sorry. I didn't share. I didn't push the button yet. I'm gonna share this one, right?
There we go. Soren's starting to share content. Looks like you may have some bandwidth problems, Soren, so you'll have to be patient with us.
One second. So this is what I want to share, right? Do you see anything different now?
Yes,
Okay.
we're good.
That's good.
It looks like you're in a little bandwidth connection to Soren, so when you change slides, you may have to wait a few seconds for the bits to propagate.
Yeah. I learned already this because I didn't letting it come out. Okay. So this is a draft that I was recommended to start working on by the working group. The last meeting in I think it's Montreal was when we decided. And there is a draft that I worked together with David, and mostly David, clean it up. But we wanted first to present the status, and then we'll decide when to post the draft. And we would like a review of the draft, but first we have to discuss. So this draft is between collaboration between myself, David Black, and Christophe was kind enough to start review the slides. So I don't know if he's in the call today, but he's with us. So at least this one important point for us because we used some of his older drafts. So they were expired, but we thought that it's appropriate for him to be involved. So he is. I'm happy to say. Okay, now I will wait a few seconds and you tell me if you're
Bits are here.
Okay, good. So what's the motivation? The motivation is to add support to new NVMe transport protocol for PNFS. NVMe over Fabric is a Fabric extension of NVMe for non-volatile memory express SSD interface. New storage systems support NVMe over Fabric. We started support at least several vendors do that to access NVMe-based storage. The NVMe devices are faster than older SCSI, of course, but connecting them using all transport will be inefficient and it will defeat the purpose of speed and safety. So that means that new faster transports are needed. Memory of storage servers may use persistent memory, and that complicates some of the issues because if you have persistent memory, you probably have consistency issues, so we need to address those. New hosts can access remote persistent memory using RDMA. Now, what we are trying to do with this draft is extending the PNFS to NVMe support, right? How to extend the current PNFS from SCSI to NVMe. That's the goal of our draft. New transports used to connect of NVMe over Fabric-based servers instead of SCSI exist already, and they are defined in the NVMe Fabric protocol. NVMe Fabric transports could include fiber channel, RDMA, IWARP, especially undated TCP, and we are looking at PCIe, but it's not clear yet if we want to include that, although Christophe is interested in that, we're still thinking. PNFS needs NVMe layout support for all these new NVMe over Fabric transports. That's what the goal of our draft is. So we started from PNFS SCSI layout and extend to support NVMe on that layout type. Draft introduces NVMe details for PNFS server and client. There is a difference in this type of storage. The difference is that in principle, you can have the clients and the servers hosts being on the same fabric, and they can actually transfer data both ways, which is different a little bit than before. Okay, so how do we expand PNFS to support NVMe? So PNFS SCSI layout RFC 8154 allows PNFS clients to direct perform IOs to the block storage devices by passing the MDS, right? That's the starting point. This draft adapts the PNFS SCSI layout to enable use of NFS over fabric, provides fiber channel RDMA or TCP access for devices using NVMe over fabric, enable implementers to start from the PNFS SCSI layout known and the NVMe standards, currently NVOF 1.1 and NVMe 1.4, to implement PNFS NVMe layout. References the NVMe over fabric transport specifications for fiber channel RDMA and TCP. We don't believe that all the three will be evenly implemented by implementers, but we want to be sure that we cover all the things. We believe that the future will be TCP. But again, this is initially. What is needed from PNFS server? Okay, good. So first of all, requires the PNFS storage devices to support the underlying NVMe over fabric transport to provide reliable NVMe commands and data delivery. That's first critical point, which needs to be, it depends on the architectures, and we'll discuss in a second. NVMe over fabric's architecture and commands used by PNFS clients to access PNFS storage device. These commands should be recognized by the fabric. Layers are shown in the diagram. So you can see in the diagram, can you see my pointer or? Okay, anyways. So the PNFS host SCSI layout over NVMe talks to the NVMe over fabrics, the transport binding, then NVMe transport service, and then the next layer is NVMe transport and fabric protocol, physical fabric, and then the layout. So this is the current proposed configuration according to the specs of NVMe over fabric and NVMe. That I, that's was the hardest part for me, is to collapse to see what pieces are strictly necessary. I'm not 100% sure that this is perfection, but that's the current thinking. And of course, we're open to see that. Now, so in any case, we want to focus, as the media is so fast, of course, it would be reasonable to assume that we want to use some kind of RDMA transfer protocol for PNFS and NFSV4 too. The NVMe port ID supports multiple NVMe over fabric transports if more than one transport is supported by the underlying network fabric. So in principle, it could support iWarp, Rocky, or both. The diagram illustrates, again, we're focusing on these two, but it's just our first draft. The diagram illustrates the layering of the RDMA transport and common RDMA providers, iWarp, InfiniBand, and Rocky V2, with the host and NVM subsystem. So you can see in the diagram, the NVMe host is connected to the RDMA. RDMA could use either iWarp, InfiniBand, or Rocky through the RDMA fabric, which again, could be any of them. As the diagram shows either of them, or all together with different hosts. And then the RDMA transport, and this talks to the NVMe subsystem. Separate TCP and FC transports are not shown, but they are. We're considering them depending on, we don't know yet what implementers will prefer. So I think we want to keep these things on.
The draft we've written to support all the transports. The diagram just shows RDMA, so we don't clutter with all the examples.
So we have to share the draft, and we have discussed about it already. Right? The draft is available, but it's not to the point that we are completely sure that we put the right thing, all the right things that need to be there. So that's why we're trying to learn a little bit from this discussion, and then we will post it and we'll open for discussion again. So NVMe Fabric allows multiple PNFS clients to connect to different controllers on the same subsystem, PNFS storage device, right? So you may have multiple hosts, multiple PNFS clients that could talk on the same subsystem to multiple devices on different NVFs. An association is established between the host and the controller when the host connects to a controller admin queue. So all this is established at the beginning before you start using it for the transport. You have to have this creating the queues, which is maybe a little bit different than previous media and previous controllers. The PNFS client also acts as an NVMe host, and NVMe controllers are used as the PNFS storage device. What means this is because they are connected to the same fabric. In principle, it is possible with the NVMe fabrics to move either way. So it could be either using the push or the pull model from the perspective of the RDMA connection and transport. PNFS clients may connect to PNFS storage devices using different network protocols, as I mentioned before, and different NVMe over fabric transports. And in principle, there should be no conflict using multiple. But again, this is a part of what we want to assert in the draft. The NVM subsystem may require a host to use Fabric secure channel, NVMe in-band authentication, or both. So that's an important point, because now there is this freer movement between the clients and the server. It is a potential for clients which are not allowed to connect directly and mess up with the data in the server, which was less possible before. Now it's more open for that. So that's why we need to be sure that we implement the secure channel fabric in this environment. Okay, so let's talk about the little details. So volume identification, PNFS SCSI layout uses SCSI device identification VPT page to identify the devices used by the layout. And we will continue to go on this path. NVMe over Fabric storage devices need to provide analogs, unique identifier based on UI64 and NGUID identifiers. We'll have to work out on these details. We have some ideas, but in the draft, but I think we are not yet sure what the implementer's path will take. UID identification could be added, but must use a large enough enum value to avoid conflict with possible future SCSI changes. So what's happening is that we need to prepare for a wider, because as you understand, connection between on a large fabric could happen, right? So we have a large number of hosts and a large number of servers on the same fabric. So we believe that we may need more bits. And David, correct me if I'm wrong.
So what's going on with the UUID is that it turns out that in the actual SCSI layout, the identifier numbers have a really nice correspondence to SCSI standards. There's no UUID in the SCSI standards, and so the trick is to use an enum value that stays out of the way of SCSI possibly doing something useful in the future we might want to pick up.
Yeah, so that's it's a wider possibility, but we need to be sure that we address it properly in the draft, and that's why we assume that there's the path, but we want to because there's the registration too. So we'll have to figure out.
Hey, Soren, hang on for a minute. Martin's in the queue. Wants to say something.
Oh, I didn't see that.
I'm sorry. Maybe I just missed it in the slide, but I don't think these slides are uploaded anywhere. Is there an actual draft online somewhere that we can read about this work?
Not yet. I wish there was. I have lots of reasons, including the TSUWG adventure that you and I are involved in, that have been diverting my time elsewhere.
Right. Okay. Thanks.
I was saying before that we have a draft 0.0, but we wanted to have the discussion first to see if we are going in the right direction, and then we update the draft. But the plan is to have it by June uploaded. Of course, we can, if there are sections that you are interested, we could share some sections. Again, it's not complete and it's not perfect. So that's why we prefer to do the right path, because we want to get a faster path to the working group acceptance. So it's better not to put wrong things that will start a lot of discussions.
Well, just personally, I'm interested in just getting some general background on this problem. I think it might apply to some use cases, but I was just hoping to frankly read the context of it more than
Yeah.
the details. So I'm happy to wait for the draft. Thanks.
We appreciate very much that, and we want people to. But you know, we were.
And Martin, I appreciate your willingness to wait. We can send you what you have now. It might cause as much confusion as clarity, because it's very much a work in progress.
That's the problem. That if you are open not to criticize us too much, just bring your opinion. We can share. But again, we don't want to confuse you. That's the problem. The biggest problem we have, right? And I think that it's very important for many people. That's why working group asked us to take over this draft. So I want to respect that. So, I mean, we want, not only me. SCSI layout uses persistent reservations to provide client fencing, right? Both the MDS and the PNFS clients have to register a key with the storage device, and the MDS has to create a reservation on the storage device. We discussed a bit more in the draft about this, so it's just sharing what we're looking at. To allow fencing individual systems, each system must use a unique persistent reservation key. Because, as I said, if you can have multiple type of fabrics accessing the same storage, same devices, it could be making the things complicated when there is persistent reservation or is done, because you know there will be conflicts in who's want to modify certain area. The MDS must generate a key for itself, and that's something that it needs to be in the protocol. And the key for each of the PNFS clients that access the SCSI layout volumes before exporting a volume. So that's important, because without this, the access to remote persistent memory is complicated. And of course, there are we can of course prevent any maldoing, but it's better to have a reservation key controlled by the MDS. That's this what my thinking was. The reservation key applies to all access by individual PNFS client, regardless of fabric, regardless of volume. So that's why it's important to have a safe mechanism, because otherwise you end up with, because the fact that each of the clients can access the memory of every other client and all the fabric makes more difficult fencing. Okay, so for the NVMe fencing specifically, we have some other additional complications, let's call them, or not complications, different. So NVMe reservation is similar to SCSI persistent reservation, which from that perspective is good. But as you know, the persistent reservation in SCSI can only connect two entities. And multiple entities will have to adhere to the protocol. MDS registration reservation, it's done, of course. But the PNFS client registration is a little bit more complicated. Multi-host reservation use, exclusive access, and all registrants. So it's a little bit more complex and more comprehensive, let's call it, than the current SCSI reservation. There are fencing actions that won't change much. Of course, we have to adapt to the protocol, to the transport, but pretty much the MDS preempt the client registration to fence client. And reservation acquire command is required, which means that it needs to regenerate a key in case that the host may not use the same key at the later time, because otherwise we wouldn't know if it was already preempted. So registration preemptions remove client for reservation and denies access, but which means that if you try to reconnect, you cannot use the same key. Client recovery after fencing, First of all, this is typical. It's not something new, but it's clear in this case that the client must meet all layouts because the data could be accessed by the remote side. So that's why it's important to commit and not to kind of freeze the current situation when you disconnect. Future get device info calls may require new PNFS client registration, which as I mentioned. Yeah, one more topic which is important is volatile write caches, because in this case, because of persistency, we may have additional conflict. How do I do with the time? So I'm trying to be short. So we carry SCSI layout volatile write cache support forward to NVMe, which is okay. PNFS server is required to commit cache to stable storage on layout commit. That's kind of a little bit different because it's
actually we're doing the same thing. What's different is just the flush command is using NVMe instead of SCSI synchronized cache.
Yeah, the flash I also I spoke before the bullet. So for the flash command analogous to SCSI synchronized cache command, it's solving the problem. Unrelated, maybe new that we are considering is RDMA flash extension a transport layer. I don't know how that work will pan out, but we will keep open an open mind.
At the moment, the initial analysis is that it doesn't apply. What RDMA flush is used to do is if you do if you were doing NFS write over RDMA, you issue an RDMA flush behind it to make sure the written data is stable before the write the NFS write completes. It turns out that for NVMe fabrics, the RDMA control path runs the other way. And so when an NFS write is done, what happens is the storage destination of that write turns around and issues an RDMA read to go get the data. And as a result, we don't need the flush command. In that case, and in the reverse direction, there's no requirement for stable data on NFS clients. There's no point in sending a flush upward from the storage to the client for the read data. It's just put here to make sure we wrote it down so we don't trip over this one again.
And it's important because it's a little different than what we know. As I mentioned before, you could in principle use for RDMA push or pulls. This will make a differentiation between the two, I think.
Right, and in particular, and NVMe in particular, transport expect that the storage is always in charge of the RDMA. The RDMA op is never originated by what NVMe will call the host, which in this case is the PNFS client. Okay, moving on to status.
Yes. So thank you for probably I'm out of time. So we have a working group milestone, use NVMe in accessing the PNFS layout. The current date was supposed to be August, but it took a little bit more work. First of all, there were some changes in the NVMe over Fabric versions since we started, and we wanted to be sure that we reflect those. On the other hand, we had some thinking about using the TCP because that's the preferred way that people are talking about in the industry. So that's another thing that kind of we wrote something in the beginning, and then we thought that maybe we should emphasize the TCP part. The initial drive will be submitted sometimes after the meeting. As I said, it's raw, it's not yet ready, but if the group is interested, we will share. And of course, we'll accept any ideas and anything. Just if there are confusion, maybe that's the first step will be to discuss to prevent any confusion. Expect to ask that subsequent draft version be adopted for what working group milestone is. We'll want to adjust date for that milestone to August. It's kind of early because we made changes. So we think that we suggest end of the year, or January 2021. That's it. That's all I have. If you have questions, I don't know if there's much time. I see a question already. Wait a second. Let me see if I can see this question as well. Let's see here. Escape. Okay. And then can I see this? So let me going to stop sharing, right?
This is Chuck. I've got a question.
Yeah, sure. Okay. Now
I seem to recall there was a draft that Christoph wrote. What is the status of that? It's expired, I'm sure, but was it not appropriate to re-advance that work?
We're picking up. We've picked up that draft from Christoph. We're going to go bash it into shape and submit it probably in a month or so. Christoph's part and parcel of this effort.
Right. Well, there's an effort here to submit an OO. I would think that if you're resubmitting this one, it's not going to be OO. It's going to be something like O1 or
It's going to turn out to be an OO because we're changing. We're changing the primary author.
Okay.
And
That's
plus,
the only reason for that.
yeah, and also we used a lot of that draft, right? I mean, we merged the draft, but we had to add way too much. So, and also you remember that Christoph was not interested. So we actually collaborate with us, which is good. I'm very happy. But we took over. So that's why we call it 0-0. And in fact, maybe it doesn't make sense to call it 0-3 because 0-1 and 2 are expired for a long time. So I don't think that will be useful. That's my opinion.
Yeah, I agree. I'm glad to see that it's moving forward. There's relevance to the presentation I'm going to make later. Obviously, I have it on my slide.
I wanted to mention your as a
We sort of obliquely referred to your flush primitive, Tom. We got partway there.
Yeah, that's great. No, it's fine. I support it. I think it is appropriate to retitle the document. I mean, if you were building on that document and intending to take it to its logical conclusion, then maybe keeping the name for now would make sense. But it sounds like you're adding some significant content, to broaden the discussion. So I think it's perfectly appropriate. I mean, we have the possibility of updating it. Let's just do the right thing. Why be tied to an old name?
And in any case, I think it's good to collaborate all together, me including Christoph, because we have new ideas for the new stuff, but we still base on his initial thinking. So I was real uneasy when we were not sure that he will want to contribute. So thank you, BP, for helping.
There is a question in the chat room. Bruce asks if there is a working prototype.
Probably not, because that requires an implementation of NVMe reservations. We've got a little bit of chicken and egg problem there.
So you understand the protocol was just finalized in June, right, or in July. So I don't. I have plans, by the way. I have plans for to look at this, right? But in plans in a sense that even I tried few things, but not at the level of the protocol yet. So I think that it will need some more work. I would prefer to do something when we decide which path to go, and I assume that if the group is confident that's important, maybe when we become a working group item, then I will probably provide some implementation. I have something already done because our product uses NVMe over Fabric.
Okay, do we want to have any sense of a consensus about whether this is the right approach? I mean, it seems good to me. So I think that was the main ask on your last slide.
Yes, yes. Yeah, sure. I mean, I would be more than happy. I think it's important, and I believe that if it's not important today, it will be important in 2 months. I can tell you many vendors starting to look in this direction. From experience in spec, I know that. So,
So is the ask to make it an NFSV4 working group item? Or is it that
there is an NFSV4 working group milestone. The future ask will be when you have a -00 draft to look at. The ask will be to adopt it as a working draft against that milestone.
That's pretty much what we want. We want, first of all,
Well, that will take a little bit of time after we have the actual document.
Correct.
So let's
sure.
just get that submitted and then ask.
Yeah, that's the plan.
That's the plan. We didn't ask for now. Yeah, we just mentioned that there's the direction, but until we don't come to a consensus, there's no point in.
The original plan was to have the draft submitted in time for this meeting. Between my day job, my wife deciding to have her second knee replaced earlier this year, and the coronavirus, that didn't quite work out.
Okay.
So I'm gonna bring the ball back to the host, right? Which is NFS. I don't know if Dave, it's you or who is it?
I think it should probably be Chuck, I guess.
Chuck. Okay, so now I cannot. Now you have to pass it to Chuck.
And I'm going to drop at this point. Thanks very much, everybody. This is David Black.
Okay.
So actually, I'll start, but I think the sharing token should be passed to Lars.
Let me do that.
Okay.
He's not presenter?
Yeah, he's going to, well, I'm not sure exactly what he's going to do, but we had planned a demo of the GitHub template for RFC drafts. And so I can say a few words of introduction about this, what we're going to demonstrate here. Probably the first thing that I remember when I started to participate in this working group is Tom Haynes using GitHub to publish the editor's copy of his drafts when he was working on this. And I kind of adopted Git and then later GitHub and for my own work. And then a couple of years ago, I was talking with Lars about this, and he said, "Oh yeah, now we have this mechanism that allows you to submit draft revisions directly from GitHub." And I'm like, "Oh, that's cool." And so I tried that out, and I sort of got myself hooked up with this template. And then I attended the Quick working group meeting sometime in 2019, probably IETF 105. And I saw exactly what they were doing with this, and it was a whole lot more than just managing commits to internet drafts. And it looks like this is something that we would want to adopt to manage working group documents to help us track consensus items and decisions and problems with the documents and comments. So with that in mind, I will pass the baton to Lars and let him get on with it.
Sure. Hey, can you guys see my browser window? Is stuff readable?
It's okay.
Yeah, I can make it a bit bigger maybe. How's that? Okay, so I should first mention that there's not really any sort of globally sanctioned way in which working groups can use GitHub. Every group is sort of doing its own little thing, and Quick is maybe more aggressive and far out there than others. There was a GitHub working group. I don't know if it's just concluded or if it's still sort of in the last stretch that is trying to write up some text about what you could do there. So there's an RFC, and I can try and find it and forward it. Well, there will be an RFC. There's an internet draft at the moment. But yeah, so basically, Quick, we basically copied a lot of what we're doing from the HTTP working group, which isn't surprising since that's the main workload that we're currently carrying. So we have created an organization on GitHub to start off with, which is called Quick Working Group. And it has a webpage that is also hosted on GitHub, which is a little bit more friendly for newcomers to consume compared to the data tracker page. So there's not a lot on there at the moment other than the documents and how people can contribute and so on. But it looks a bit nicer compared to like the data tracker complicated thing with 10,000 buttons. And under this quick organization, we have a variety of repositories. So we have one called working group materials that we're using for keeping all of the stuff for the various meetings. So for each IETF, we make a folder. For each interim meeting, we make a folder, and we sort of store, you know, the PDFs of the presentations, the agenda as markdown, the arrangement as markdown, minutes as markdown. And that's sort of our main repository. And since we're required to use the data tracker for archival purposes, we're also putting everything on the data tracker. But our working copy is usually on GitHub. And sometimes we forget to put stuff on the data tracker for years and nobody notices until somebody does. So that's basically how we're using, you know, work group materials. And I think many other groups are doing this too. And then we have a repository for each internet draft that we're working on as a working group. So we don't put anything in here that isn't working group adopted. That was a decision. Some other working groups allow individual drafts to already move themselves under the working group organization, but we basically say once we have consensus for adoption, that's when something moves. And since GitHub lets you move repositories now between organizations or from an individual account to an organization, you don't necessarily lose the history. You can actually move the existing repository that somebody like, you know, Chuck maybe already has under a hypothetical NFS working group GitHub organization. We have a little bit of a wrinkle in that we have a bunch of drafts that are very heavily related, and we're calling them the base drafts. And there's a few of those, and they live in one repository because when we started, GitHub didn't let you move issues between repositories. And the base drafts, we often found ourselves wanting to move an issue that somebody had opened against one document to another document because it actually, you know, the text moved or something like that. These days, you would probably really make that different, but we didn't. So there's a README, and this is basically Martin Thompson's ID template that Chuck has mentioned that lets you write documents in Markdown and with a sort of continuous integration back end automatically submit the XML to the IETF. And Martin's template generates this nice README thing that has clickable links that generate, you know, diffs to the what's called the editor's copy, which is a snapshot of the current GitHub version against the last IETF draft and so on. And we're using it quite heavily. Right. So that's basically how we're organizing our materials. This is nothing sort of earth-shattering. We have some teams here for people. So we have this group called what is it called? Well, we have the chairs, right? Which is the three of us that have, you know, full access to everything. We have a group we have a team for each of the editors of the different drafts. So the base drafts, they have a group called base editors who have write access to that repository. For the other drafts, we have datagram editors and so on. And then on the bottom here, you can see a team called ZH Chinese Translators. These are a bunch of Chinese people that are translating our drafts into Chinese, and they have their own repository with their work, so they have a team too. This is mostly so that we can do access control so that, you know, only editors have actually write access. We have a team called contributors, which is sort of pretty big, as 30 members. This is sort of basically everybody who wants to be there gets added to that. That's because in GitHub, you can only assign issues to people who are somehow in a team that's associated with the organization. And so if you want to give somebody who isn't an editor the ticket to work on an issue, that person needs to be part of some team, and that team here is contributors. So that's been growing over time, and we just add people there as needed. And also, if you want to have somebody else review something, right, you can do code review and so on, which we do on the spec, and you can also assign them there. So that's what we have the teams for. Right, something that we're using very heavily is issues. And this is quite a busy, so this is the base draft. It was our main specs. You see we had 5,800 something commits Since we started with 70 contributors, we had 139 releases. So there's quite a bit of activity. There's at the moment 25 branches. We have a bunch of open issues. You see that those are also, we have 3,600 issues that were, worked on during specifying quick. And we have a bunch of labels that we found useful. And again, this is up to each working group to define what they find useful. We have labels for, which draft in this base drafts repository is this issue related to? Is it the HTTP draft, the invariance draft, recovery, and so on? And then we have labels that have a different colors that we sort of use. One is like, is this a editorial issue against the draft, meaning this is like a wording change or something that doesn't touch standards level text. We have decided as the Quick Working Group that we let the editors of our documents just deal with those without doing consensus calls. So the chairs label the issues, and if we decide that an issue is editorial, we label it as such, and then the editors go and take those and assign it to whoever wants to work on it, and they fix it. Conversely, if something is labeled design, it actually changes the current consensus on operation of the protocol. So somebody wants to like add a must or add a new protocol mechanism or something. Those issues get labeled design, and those actually get then last called in the working group and progress through a pipeline. And these other labels down here, has consensus, invalid, needs discussion, parked, and so on. Those are actually some that we use for keeping track of where stuff is in this consensus pipeline. Pull requests is, so issues, we have a pretty distinct rule that, so issues change are basically diffs against the spec, but we don't allow discussions on issues, on pull requests. We want the discussions to happen on the issue that's associated with the pull request. This is again, just by convention, so that you don't have to like always remember whether something was discussed in the issue or the pull request. And what we use pretty heavily is this project board. And you can have many project boards. Quick has one, it's pretty big though, which is called late stage processing, which is where we're in. And this is sort of automated. So GitHub lets you automate sort of a workflow here. On the bottom here, you can see that it says automated as to do. So when somebody opens a new issue, we basically put it in triage, where it lives in this column here, and the chairs monitor the discussion on the issue, and in order to decide whether it's editorial or design. And when something is editorial or design, we label it, and then the automation then puts it into either this editorial issues column, where everything is green editorial, or the design issues column, where everything is blue and has a design label. So that's automated. And as I said, the editorial ones that the editors pick up, fix it, and when it gets resolved, it goes all the way over here to issue handled. And then you can see that there's a bunch of editorial and design ones. The design issues, we leave in this column. They get worked on. The working group discusses them. And when, again, the chairs and the editors of the respective document that the issue is filed against feel that consensus is emerging, we label something as proposal ready, which would move it from this column to this column. Once they've been sitting here for a while, we then email the list and say, hey, these issues seem to have gotten consensus on GitHub. We want to confirm that on the list, and we start like a working group last call on an issue and say, if you object to the proposed resolution, you have 2 weeks or something. And this then issues end in this column called consensus call issued, which is this nice pink. And once that period has expired, we basically say consensus declared, label it, and then the editors can merge the resolution to the issues into the documents, and the issues finally go over here. So this is, you need to run through this a couple of times before it makes sense in your head, but it's been very helpful for us to have this, because as I said, we have 3,600 issues. We could not have done this by email or something like that, or in any other way that we could easily think of. And since everybody is sort of familiar with GitHub these days, it also lets other people work on this pretty easily and get up to speed. there's a few other little things that we've done. We have, obviously, we have the quick working group mailing list, but we've also created, so we had some pretty strong pushback that people said, we don't want to join, I don't want to join GitHub to work on the spec. I want to work by email. And that's fine. I would still encourage people to get familiar with this. It might be helpful to have this on your CV. But for the people who absolutely want to use email, we basically created another mailing list called Quick Issues. And that is subscribed to all the repositories of the Quick Working Group organization. So that mailing list is subscribed. And so every time somebody comments on an issue or does anything, an email gets automatically generated by GitHub that goes to that mailing list. And so you get hundreds or maybe sometimes 1,000 emails a day to that mailing list. But if people want to subscribe to that torrent of information, they can then reply by email, and it ends up in the GitHub server, and GitHub extracts the stuff and puts it into the ticket, and everybody else just sees it on the web. So it is possible to work on this or follow the Quick working group if you don't want to be going to GitHub.
People doing that is
at least 2 or 3 are.
Okay.
So nobody's actually implementing Quick, or none of the sort of core contributors. But we have a bunch of people who sort of are congestion control people, for example, that are just interested in making sure that the Quick congestion control works, and they seem to like email better than GitHub. So yeah, so that's sort of all I can really remember in terms of what we're doing. There might be some more things that I'm forgetting now, but those are the highlights. So it's been very helpful. I will certainly do this for any other working group that I end up chairing in the future. But it does require, really strong buy-in from the community. And for Quick, it was easy to have that because we started from scratch, and also our, engineers are, I would say, at least in transport, if not in the IETF, they're probably among the youngest participants that we currently have, right? Everybody's like in their 20s or maybe early 30s. And so for them, this is oftentimes the first time they do an IETF group. And so doing it this way was not any different for them than anything else. And it really let us sort of keep track of stuff and move pretty quickly, which is nice. All right, I think I spoke for too long. I don't know how much time I had, but we can do questions, or you can send me email, or as you wish.
I think at one point, Dave Novak had some concerns about IETF legality around this, putting this kind of stuff into a public Git repository before it's actually submitted. Dave,
I was worried about getting pushback because of these dead periods, which I don't like, but I'm sure we'll get some pushback on things like that.
So there's no difference to it. So as a working group, once something is adopted, you can work on it in this form. But even private drafts get worked on GitHub, so there's no legality that's really a problem here. We have, I don't know where we have it. It's certainly
on
the main page here. So basically, we have contribution guidelines up here. That are, again, GitHub wants you to have these anyway for your repositories, and it says about, do you need to follow some pointers to the IETF list and rules, and this is some boilerplate text.
I think the main point here is really that anything you submit into the Git repository or the Git is considered IETF contributions. It's up on the participants to, the same way as you submit the draft. If you submit a pull request for a text change, you are promising that all the copyright rules, all the other things that apply to the text also applies for this pull request, for example. So, or the same as you would send an email to the mailing list, it's a contribution to the IETF. This is applied in the same way.
Yeah. One thing I should also mention, which isn't GitHub, but it goes hand in hand with it, is that we have a very active Slack. It started out as a Slack channel for the different teams and the different companies and organizations that are implementing Quick. So it's mostly focused on interop, but it turns out you can't really separate interoperation from specification. as you guys probably know better than we did when we started this. And so in the beginning, we said the Slack channel is, not under the IETF node well. And that became quickly impractical because people just started discussing, oh, we need to change this in the draft because the interop is failing here. And so we decided that the Slack channel is also under IETF node well. And at the moment, we have like 233 people subscribed to that Slack channel. So it's pretty big. And since we're using the free instance where you only get 10,000 messages, 10,000 messages on that Slack is basically 6 weeks. So it's very, very active, and there's 20 or 30 different channels. And most of the discussion, if it's not on GitHub, it's in the Slack. And the mailing list for Quick is surprisingly quiet given the amount of work that's happening. And the Slack is sort of open. Everybody who emails the chairs can join, and if you're in there, you can also invite others. So it's not like locked down to chair approval, but that's been a very good resource as well because it makes collaboration much easier, and specifically for these 20, 30-year-old engineers that don't really understand email, Slack they do understand. So if you guys are thinking about using GitHub for NFS, right, I would sort of maybe start slow and move the documents there and try, and then maybe for a new document that you're starting from scratch, try to work with GitHub issues instead of email issues, and try it out sort of maybe with one document or so and see how it works for you, and then if it works well, migrate more of your work over. I would suggest a small document first, maybe.
So I've been doing that with my personal documents, and you've shown us an enormous amount of process here, which we probably won't need because we're a much smaller working group. But it seems like managing our working group documents in a common Git repository might be useful. I know that we're looking at tackling a very large effort with renovating RFC 5661, which is almost 700 pages. So this might be helpful there. That's my commendation.
Okay, so okay, let me think about that, and when I make my plans to do that, I'll consider that, and we'll talk about it, using it for that document. Okay.
Yeah, and to be clear, I mean, if people are very used to XML rather than Markdown, there's no, I mean, you could stay with XML. I don't know how well the kind of submission part of this works, but it's all the building tools, etc., for the Git, etc., works fine, even with XML. So
it certainly does. I've stuck with XML. I haven't switched to Markdown. All my documents are XML source.
Markdown has the one advantage that it's a bit nicer looking on the web, because Git has some magic that can make Markdown diffs look okay. I don't know how well that works for XML, and it's sort of easier to do copy and paste with Markdown compared to XML formatted text, but you certainly can do it with XML.
I had several projects, and I had to scratch my head with XML.
I mean, if you look at the markdown of the documents here, right, they sort of, you can basically read even the raw markdown pretty easily, which is not necessarily the case with the raw XML.
Yes, that's exactly what I saw.
That isn't true. The raw XML is really easy to read.
I'm not going to get into the debate.
I did a 700-page document with it. It's easy.
Maybe after 700 pages, it becomes easy.
Well, one big issue is that the big project we were talking about taking on is a revision of, like you say, a 700-ish page document that is already in XML. So I don't know that anybody wants to take over figuring out how to reformat it all into something else.
Scripts. So some people have done exactly that. So there's some automation available. I don't know if it's fully automated, but what they have done is basically you submit a 00 of your BIS document that is just the XML to Markdown conversion, so there's no other changes, and then you take that as the baseline and then move forward. But again, this is up for you guys to decide. I'm not touching that document. Not qualified to write NFS specs.
Okay, well, maybe
we've taken
we'd
enough
also
time.
need to think about possibly how we'd handle changes. I mean, another thing we might want to do is take work through the changes that we have in Git logs of the existing document of other documents to bring them into this document. I don't know if that would make that more difficult.
So I think we're about 15 minutes behind now, so we'd probably best move on to the next topic.
We should move on. I think that's you.
Yep. I have the ball.
Yeah. Oh, let's see. Let's see how to do that. Okay.
I gave you the ball.
Okay.
Hey, everybody. This is Brian.
hi.
Etherpad is acting funny. People are typing things, and the list of attendees text just appeared within the notes in minutes. So, not sure why, Magnus.
Okay, this is a directory performance scalability. I'll try to be quick. And in fact, I don't think there's much here to present other than just a problem statement. So I'm sure all of us as NFS practitioners have received anecdotes from users and administrators over the years about the problems with managing applications that want to use directories as just a flat namespace. That's quite problematic. It's problematic for POSIX file systems in general, but especially so for NFS for a variety of reasons. We also have this problem where the server can vary the set of entries in a directory based on the permissions that the requesting user has. I don't know if that's probably today's implementation, but I'm told that's going to be an issue eventually. I guess SMB does this. I'm not sure, not an expert there.
Yes, SMB does. It's called access-based enumeration, ABE.
Yeah. So I think this would be a problem for multi-protocol NFS servers that allow access to a directory both via SMB and via NFS. And a third problem is the age-old UNTAR problem, where UNTAR seems to proceed very serially through its tar file, and it creates directories and files one at a time, and it's completely synchronous with the server's backend storage. And that's increasingly a problem for these data center area file systems where you've got multiple copies of every block behind an NFS server target, and there's a replication protocol that's going on back there that makes these things very slow. So they are not very fast with individual creation operations, but if you send them a bunch of operations in parallel, then they seem to do pretty well. They will scale. And UNTAR just sort of flies in the face of that whole paradigm. So I think we've been telling people, if you want UNTAR to go fast, you have to write a special version that parallelizes the UNTAR process. And some people are taking up that challenge, and some folks are like, no, UNTAR has to work fast. So I kind of boiled down a set of scalability goals to help us focus the conversation a little bit. We're really dealing with a lot of legacy applications, especially some we found that interleave get dense read dir operations and directory modification like creations and deletions. That's a real problem for NFS just because of the way most NFS clients cache directories. Now we have our usual bag of tricks here for making things faster. You know, make this server faster, the durable storage on the server faster, use more aggressive caching on the client, make things parallel, like I was mentioning before with untar. You can untar things in parallel rather than sequentially. Make the transport faster to get the data back and forth between the client and the server faster. And then, of course, the one that we've been playing with most recently is server offload, where we've got copy and clone operations. But somehow these tricks don't seem to apply directly to the directory conundrums that we're facing. So, you know, I've tried to write down some solutions here. Maybe people have other ideas or think my problem statement is way off. So I'm open to hearing comments at this point.
Okay, you mentioned direct write delegation. So we don't have that, but we do have directory read delegation and notifications. Have you looked at that? And first of all, I'm wondering why that hasn't been implemented. And second of all, I know whether it might help.
Would a directory read delegation would a directory read delegation help for untar?
No, it wouldn't.
Yeah, I mean that's a pretty common workload.
Certainly wouldn't invalidate. I think my hope would be that by using notifications, you could avoid continuing to destroy the cache. I haven't looked at that, but
well, it's not a problem of
that's
you
my
know,
question.
other.
How helpful is directory redelegation here?
So let's take the multi-client cases out of this consideration and think about only the single client. The single client is going to, when it creates a file in a large directory, is going to create that file, and then it's going to invalidate its directory cache for that directory. So
it doesn't have to.
It doesn't. Why not? I mean, the server is completely in control of the cookies. It has to read all of those cookies back from the server because any one of them or all of them could have changed.
Well, there is a provision for notification where you're notified of changes, and the assumption is that is probably enough, or it might be enough. Maybe we need to, it may not a valid assumption to say everybody can change every cookie on every operation. I mean, that's a way toward dealing with that.
Well, the fifth bullet down is sort of in that area. But it takes a different approach. It would be where the client asks the server for a range of cookies that it can use. And then it is free to do creation operations without contacting the server again until it's ready to find out what the creation M time and C time is of each individual file, although that's not in directory entries. But anyway, the client, you know, being able to, I guess we could think of this as a reverse server offload, where we are asking the server for a set of resources that the client can use at its own whim, and then when the client is done, it can write them all back and could get back the unused ones, and it can tell the server, oh, I actually use these for these files, and it could be entirely asynchronous with applications.
It's sort of like getting a layout on a directory, being able to write the directory yourself, right?
Yeah.
But okay.
No, it's like getting delegation on directory. It's not like getting.
Well, a delegation sort
I
of.
don't know about layout. Okay, I have a different approach to layouts, but anyway. All right. You can go on. Sorry about that.
All right. Well, the wrap up here is that I don't have a document here. I'm not sure how to approach the problem, and I don't think we have any good solutions here. But I would like further brainstorming. I'm not sure how to go about doing that. I guess it's up to us implementers to come up with some idea and then see if people think that it's going to be able to apply without issues on other for other implementations. I mean, the implementation of file system directories is pretty complex, and it's different in each file system, physical file system. So yeah, I'm not sure what to do there. Anyway, we can wrap this up right now and move on to the next one.
Sure.
Hey, can people hear me?
Yes.
Yeah.
Hey, Etherpad is acting crazy. I'm taking the minutes offline now. Magnus suggested that. I can't even get back into Etherpad. If you're working on it, keep adding stuff to it, but I'll be working offline on minutes.
I guess
Etherpad looks
I guess
kind of
it's up to me
okay
to
here
do
to me.
slides now. So I have to share something, but it seems to have event. Okay. Let's see. All right, let me see how to share. Chuck, are you still hold this? So you have to give this permission back to me?
I think as the host, you can take it from me.
Okay, all right. Change role to presenter. Okay, all right. All right, sure. Okay. This is a proposal or pre-proposal or something about perhaps improving the parallelism of directory operations. It's not, there are small points of contact with what Chuck, I'm not looking at anything on time. I'm just looking at general performance. I'm looking at situations where you have servers that are processing a lot of work in parallel, and maybe directory layouts is one way to do that. So in the past, we've had a lot of discussion of directory layouts with striping, and it didn't seem to go anywhere. And I think the reason, I'll talk a little bit later about why it didn't go anywhere. But I will also talk about why this might be follow up on, even though that is not as ultimately performant. On the other hand, it's simpler, easier to implement, and I think it might be worth, I'm presenting it because I think it might be worth people following up on as one way to improve directory performance, so not for the specific items that talked about. So the basic idea is you have a PNFS-like directory layout. And this is directed, in my case, my service implementation case, in the case of cases where we have a clustered server and you naturally put different directories on different servers, and you get a lot more parallelism if you simply allowed the client to get a layout saying, hey, if you want to do something to this directory, go here, without striping them. That provides greater handling in the parallelism. It's inter-directory parallelism within the same file system rather than the intra-directory parallelism as in the striping case. Now, I say PNFS-like because there's some differences in common as well as commonalities. The commonality is the primary responsible for a function is given to another server. The layout bestower, who's in normal PNFS, is the role of the metadata server. He can perform the function if requested, but typically clients will go to the guy who holds the layout. There's no striping. That's mainly because I couldn't see how to do striping, and I've seen what problems were. It seemed to be never ended, and the attempts to do this with striping didn't work out too well. But you at least have read and write layouts, and you have a single. Unlike the case of PNFS for data, we would only have a single layout type rather than multiple ones. All right. So why I think this is worth explaining. First of all, it's a relatively easy way of improving directory parallelism. I put it's quite easy. I think you need to provide great performance parallelism in handling of directory operators. My focus is on build environments rather than the cases. Now, one area of contact that Chuck and I both mentioned is remove R. That's some interest, and I think maybe the best way to do that is the way that Chuck is sort of offload. Treat this as an operation that you give to the server as a whole and let him tell you when he's done. I'm assuming enough jobs to avoid the need to parallelize single command. So that's no different from my approach, my talk and Chuck's. Now, many attempts to do striping have not resulted in improvement because the support directory strip, they've not worked out. I'll talk about that in the next slide. That was based on my post. I just saw lots of messages on the system. I tuned it out, and somehow the process all died. And it was what I'm assuming is that there's probably not. If someone is interested in resurrecting that, we could resurrect, but I'm not. And the other issue is, well, we have delegations and notifications in RFC 5661, but they're not implemented, and I'm not sure why. And I think I'm not asking if someone knows and can speak up. I'm also asking for discussion of this on the list. If we have this feature, is it because it was wrongly spec'd, wrong thought out, not the right thing? If so, can we improve it? Can we work to implement it? I don't know. I think we should be looking at that, as that's a big piece of RFC 5661, and I don't know why it wasn't implemented. All right. Now, we have had many people, as I said, work on striping of directories. But the problem is, it's hard to stripe because there's no obvious correlate for file offset. There are hashes you might use, but it's hard to get agreement on the client, the server, the on-disk FS. And I saw this discussed endlessly and just figured maybe it's not worth it. And it is that kind of thing is necessary for performance of extremely large directories, but how common these are. They're more common than I think, but it's also a question of how common they should be. And maybe that's just the wrong thing. And maybe there's no real percentage in trying to make those perform well. But this is a good way to provide within directory parallelism. That's better than only provide striping is a good way to provide it within directory parallelism. It's better than only provide inter-directory parallelism, but so far we don't have it. There's no expectation we will have it, and maybe we should just move on. Now, possible alternatives to this is, well, directory delegations, and Chuck has mentioned directed write delegations. And I think much of what he's talked about makes sense, but my sense of how things work is that if we can't get people to invest the effort in directory read delegations, it's hard to believe that we'd get the people to invest in directory write delegations. They're so much more complicated. So why weren't directory delegations? Yes? Question? Anyway, the delegations of 56s were never implemented, and we need to understand why. Might be simple inertia. If it's that, maybe just people should start thinking about it. I know a number of people have mentioned to me, gee, we implemented file delegations, and that was not a big improvement, and that may have a role. We need to understand if the expectations for directory delegations are better. Or is there a problem with directory delegation that we can address? Now, Chuck and I in our discussion talked about, gee, the idea that, well, you've changed this one file and then potentially every cookie for every file might change. That might be a simple thing that we could address with an attribute bit saying, okay, the client may tell you, okay, yes, I'll give you notifications, but I'll agree that I will not change cookies of existing files without that. If that's worth doing, we should think about that. So, Chuck has tried to start a discussion process, and I think maybe we should have a discussion process which is focused on directory performance, not only on the cases he's talked about, but what we can do in general to improve performance. If this is an area of interest for everybody.
So Dave, this is Tom Haynes. I don't know that I agree necessarily that file delegations are not performant. That's not what we have seen.
All right. Okay. All right. That's what people tell me. I haven't. I think maybe it's not a question of them not being performant, but there are a lot of environments where they're not all that useful. I think that's what I'm hearing, but I don't speak of that as direct knowledge. But
okay.
So anyway, if we decide this is worth it, there's some protocol details to work out, and I don't think they'd be that much trouble to work out. Basically, I think there's a lot of text here, but the basic thing is you define this layout type. It works. You get a layout, and I think because of the way the rules for work, you get your own format for the layout get request and the layout return, because I think that's provided for by the way that we just define for every layout type. He gets his own version of that previously opaque structure. And I think you would not have striping for this. You'd have layout levels for read and write, and may need also separate bits for the write of the owner of the directory to respond not only to remove, rename, look up, but also to open, and that would be one way of spreading out the metadata load.
So this sounds like you're pushing the two issues together. You described a use case where you want to have basically this directory is located on this cluster server or that cluster server. That has nothing to do with your delegations that you're describing. Why do you need read write in the case of
Not describing delegations, I'm describing layouts.
Why do you need read or write layouts based on location?
No, you don't. You probably don't. But I think you always have the, well, you do have the ability to copy the thing and give everybody read layout, or decide that it's on location, give a write layout. So you don't need it, but it's a natural part of defining it.
I just don't know what it means to be different. Do you, okay, so you might say the read layout, you can go to cluster B, and it'll be slower to access if you want writes, but it just doesn't make sense to me.
Okay.
You know, it sounds like you're trying to force it into the layout definition because part of it matches. And I don't know. The other thing that's problematic to me is when you have a file layout, you only have one layout type per file system. And now you're saying, well, I'm going to have a file layout and a directory layout per system. Or are you saying there's only one layout type per system? It's still.
No, I think you point out something that would have to be addressed, yes. So there's now as a layout type attribute, and there you would need both a layout type attribute and a directory layout type attribute. You wouldn't have to rename layout type as file layout type, but that's the essence of what you're saying. It is correct.
Yeah. And if you do that, you may address the issue of I don't need read or write. I don't know.
Yes. Okay. So I'm looking to assess working group interest, and I'm not hearing a lot of interest, but I am having an interest in the general, hearing that in the general problem. And I think we have to figure out how we can discuss this on the list. And so I think Chuck has brought up some interesting issues. I think we should have a general discussion of that and see what the interest is. And I think, I wouldn't make the strong case for this. I would make a strong case for understanding why directory delegations aren't implemented and making them part of the solution if it's possible. That's it for me. Okay, who's next? I think it's Tom. Just a second, I'm going to check.
No, it's Soren.
That's me. I need the ball.
Impression attributes.
Oh, right. It's Soren first. Okay, yes. Okay, I'll have to deal with that. Okay.
Pass the ball, please.
Sorry, it looks like anybody can drag the
Let's
ball.
figure this out.
I'm allowed to drag the ball. Here, let me try it. I try to give you the ball. It tells me I can do it, but then it doesn't do it.
I know, same for me.
Oh, it does? Okay.
I try to move it and I can move it, but it doesn't stay. It goes back to whatever it was.
Gee, that is a great user interface.
Okay, where the hell
WebEx.
is
I tried last time, so that's why I know I'm
Yeah.
an expert. So David, can you please move the ball for me?
If I can figure out how to do this, okay, persistent. All right, let's see, this is Soren. It won't let me do it. No, it won't let me do this from this window. Let me find the other one.
Okay. I trust your knowledge of WebEx.
Okay, participants.
Soren, are there slides for this?
Yes, I will.
Okay, change role to presenter. Soren?
Send them later.
I'll send you after this.
Okay.
There we go. Okay, so now I need to find the right thing and okay, can everybody see this? Do I have to wait a little bit or
Nothing yet.
again?
There we go.
Okay, thank you. Sorry about this. Good. So this is a continuation of the first draft work that I had. In Montreal. I tried to take into account all the considerations from the meeting, and this draft it's my try to fulfill all that. So first of all, I won't waste too much time on the importance or use of this, but it is clear that it's related to the new media, very expensive, and generally the amount of data is exploding, while as the the media doesn't keep up. So the only best way to keep up is to reduce the data as much as possible, or the minimum. And when we're talking, even exabyte is okay, but already people are talking 2 orders of magnitude about that. So that's, I think, will become de facto every storage system will have to do the best to reduce the data. Also, the memory of servers increases because they currently can use NVMe devices, as we discussed before. And also, there are new faster NVMe fabric interconnect available as well. So that's where we stand today. And that's why it's important to try to reduce the data as much as possible before pushing to backup. So how do you address this problem? There are new data reduction methodology algorithms and compression enhancement to improve data reduction. There are new methodologies using variable blocks than fixed blocks, because the variable blocks give you an opportunity to compress better, depending on compressibility of the data. There is also a lot of work in the compression hardware. For example, using Microsoft Zipline or Intel creating chips or any other FPGA. Many vendors already use this accelerator. The data reduction require larger memories and larger number of cores. And of course, we're looking at the world right now, the number of cores explode, the number of new servers has both a lot of memory. It's not uncommon to have terabytes of memory, RAM memory, right? And hundreds of cores. What's missing is user information related to data reduction that arrays cannot know. So what we are trying to do with this draft is to offer a way to transmit the data reduction attributes or characteristics from the NFS clients to NFS server. Currently, NFSV4 has no means to communicate data reduction attributes. So our initial thinking was to use extended attributes, and it seems that it was not accepted and it was not recommended by the working group. So we are looking for different ways, other ways to use attributes. So NFS server data reduction engine operates the file system block, typically 8K assuming Linux, but could be other blocks. There is analytics, analysts data regarding compression of different types of files that can improve data reduction engines in the array efficiency. Meaning that you can, even if there is unknown the compression ratio, it's known what type of compression is used, and that's useful. There's no way to take advantage of this data, as the application DR characteristics are not visible to the DR engine, right? So we need a way to communicate this information. There is a new draft extending the PNFS SCSI to NVMe that I presented before, and we propose to use name attributes in the same context. We propose to expand data reduction to apply to PNFS SCSI. Let's see from NFSV4. By the way, if there are questions, I'm sorry, I am full screen. I cannot see the questions, so I could address them at the end. We need a way to communicate the data reduction characteristics from client to server. We propose to add few optional attributes, compression and dedupe. We don't propose any implementation solutions for DR. We just use a mechanism to transfer the knowledge. We just allow better data reduction when the data reduction engine has additional information about the target, and if it doesn't, there are arrays that do as best effort, but in many cases, if the data is specific characteristic like genomics, for example, it's not trivial. You cannot precisely say this unless there is upright information. File extensions, we assume that file extensions can indicate file type. File headers can indicate compression type also. And we prevent applying data reduction on uncompressible data using the attributes. So if data is not compressible, it's a performance enhancement not to try. So I give you two use cases. The first use case is a normal NFS server, which talks to a reduction engine, which generally it's inside the storage segment, right? To the block storage. The assumptions for use case is the NFS server can communicate with many attributes as metadata directly to the reduction engine, meaning that the client will transfer the attributes to the server, and the server will be have a protocol to connect and transfer this information to the block storage. Backend identifies file system blocks of a file and can associate to each block. So if there is information at file level about how compressible a certain file is, that can also be associated for each of the blocks that belong to the same file. In this discussion between NFS server. The other case is PNFS over NVMe SCSI. In this case, you can see that the client can talk, the server can talk to the engine, but it's also possible that using the NVMe channels and SCSI channels to transmit that information directly from the client to the reduction engine. The data reduction name attributes are accessed by open operation using hidden directory of attributes associated. The NFS server extracts the data reduction recommended attributes and pass them down to the block storage. This is some example that is not new. That's what I gave the example before. It is part of the draft. So we decided to use new recommended attributes that the recommended attributes are stored with the file system objects, should be preserved when files and directories are updated, moved, or copied. The attributes are hints for the client application regarding file compression and the duplication. These attributes are intended for data needed by applications rather than by an NFS client implementation. So it's kind of communication from the application directly to the backend. NFS implementers are strongly encouraged to define the data reduction attributes as recommended attributes, not mandatory. So, and then a client should check if these attributes exist or not. Attributes are hidden metadata and should be retrieved by the NFS server and passed down to the engine. So that's outside of the scope of this. Protocol enhancement that we are looking at. We propose enhancements to NFS protocol operations to allow recommend attributes to be queried and modified by clients. Add new attribute bitmap 4 to allow data reduction recommended attribute support. Recommend attributes may be examined and changed by normal get after setup operations. I think this was a conclusion from last time, and I think it's positive. And returned by open command. And attributes can be modified by users and stored with the file system object, both files and directories. So again, what we'll ask this time, I would like to the opinion of the group about adding such data reduction attributes to the NFSV4 protocol as named attributes or any other that would be the current intention. Should this become working group item? Should we first define the protocol changes to support DR before adoption? Is the working group interested in data reduction attributes as defined in this draft? We want to ask for the working group review of it. Now, what I just want to mention, there is interest. But as you know, I'm in the spec committee, and there's a interest in that space for the spec for this type of data reduction attribute. So it's I don't have many customers to know that that's correct, but there are some of our customers that are asking questions regarding that. So thank you very much. And I upload the slides when I'm done.
Soren, are you going to take this to the working group alias to follow up?
Yes.
Okay, please.
Yeah. Sorry about.
Okay, I have a question.
Yeah, sure.
Are these the attributes defined in this draft?
Not yet. It was just, I want to be sure that it's acceptable by the working group to have such attributes.
No, you can't. Doesn't work that way. You propose the things, and then we're not going to say, oh, if you do this, we're going to accept it.
No,
propose it, and then the working group can consider it.
I explained. I'm saying that I presented first time, it was not accepted. I present again, just a new idea. So if I can pursue it, if I should pursue it, of course, we'll have implementation more detail. Sorry.
I think
the first time
you should define the attributes and then see whether there's interest.
Okay. So, but the question is, what kind of attribute? That was the discussion last time. That's why I had to present again. Understand? Because last time I used extended attributes and nobody accepted that. So now I changed that. That's the novel. There's a difference from the last time. So I don't mind.
I think the working group agrees that these are normal, so-called recommended attributes, but you have to define what they are.
I'm gonna be fine. Look,
and until that, anything regarding adopting the thing, whether it's a working group item, all that stuff is all premature.
I know. I'm just asking. So now I know you want to have more meat, and then we'll try. But
I don't want more meetings. I want a document.
Yeah. I'm saying updated document. But what I meant is that I didn't want to waste time if nobody's interested in these types of attributes. That's my point. So that's why I tried.
We don't know whether we're interested until we know what they are.
Well, the question was useful then. Of course, we find the right definitions, but it's a question of does it work? Is it anybody interested in using?
Soren, I think it's useful to raise awareness, and we're certainly watching your presentation, but there's only a couple of handfuls of people here. The working group at large is, needs to be engaged. And I agree with Dave. We need something more concrete. Your ideas are interesting, but it's not up to the level of saying, yeah, we should proceed.
Well, at least I would like to have somebody review the draft. That's
good. Yeah.
So I'm a little concerned about the first bullet on the last slide there. Why are you asking about named attributes? I'm not sure that the takeaway from the last presentation was that we rejected extended attributes. I think we said use regular FATR4 style attributes. Don't use extended attributes for this. So I'm not sure why you're coming back and saying, well, should I use named attributes? I think we told you what would be acceptable for this.
I don't see that you told not name attributes. I know about the extended attributes. I just asked. I don't have an intention to use them, but I'm asking.
No, I just don't, I'm trying to save you some time. That's all. I'm not criticizing or anything. I'm just, the comment is, I don't think that takeaway, you mentioned the takeaway about extended attributes. I'm not sure that is exactly what we were trying to communicate when we did last time.
I thought that was, I don't know, that was my perception from the discussion that.
Well, we did say don't use extended attributes, but we did not say, but you should try named. I think we recommended specifically use a FATR4 attribute for this.
Yeah. No, but the point is that extended is not acceptable at all, right? That's what I want.
It's not, but neither would named attributes be.
Yeah, I know. I'm asking, do you prefer named attributes? My intention is not to use named attributes, but that was
okay. I think we should move on.
Yeah. So I'm done. Thank you.
Right. Yeah.
Slides. Ball back to you, Dave.
Okay, sure. Let's move on to Tom. Who's next, I think?
Okay. Now the presenter. Okay. Oh, somewhere up here. Is that showing for everybody yet?
Yes.
For me.
Yep.
All right, let's get started. I have 7 slides here. I'm going to try to move quickly. You have perhaps seen some of them. I forwarded these slides to the mailing list about half hour, 45 minutes ago, so you can see them there. A brief introduction. The flush extension is a proposed extension to the RDMAP and DDP protocols, collectively known as IWARP. It supports 3 new operations: flush, which is a placement guarantee for remote visibility and remote persistence, a little stronger, and a 2-way acknowledgement of the state of data that you have previously written. Second, atomic write. It's a transactional 64-bit write, and it's ordered to flush. It's used, envisioned to be used primarily by things like log writers or replication, where you need to replicate the data, make the data secure and safe, and then mark the data as present, like a log writer pointer update. And third, a verify, which is a hash calculation of a remote region, which can be used to verify the contents. And these 3 operations are present in a draft that I'll mention in a second. There's a similar effort underway in the InfiniBand Trade Association. This is the organization that owns InfiniBand and Rocky specifications. It's being published as an annex. The effort in the IBTA and the IWARP proposal that I published, that we published the draft, they're compatible semantics. They're slightly different in that the IBTA extension does not currently include verify, but it's been discussed there. It was actually skipped in the interest of time. That decision is looking a little silly now that it's dragged out in a long period of time, but it's not off the table. It's just not currently present. The Flush Extension IETF document is a document that I first published with a Microsoft co-author in February 2016, 4 years ago. It was called Draft Healthy RDMA Commit, and you can see its data tracker. It described at the time the fundamental requirements and concepts. It made a sort of a draft of a protocol, but it didn't jump to that conclusion at that time. The idea was to lay out the requirements and concepts only, and to begin the draft of a protocol, but not actually specify it. There was a lot of consensus on it. I got a lot of traction on it. I presented it at Storage Developer Conference, at IETF, at RDMA conferences. It's been the approach of choice for everybody, and there's been significant work offline, including the IBT effort. Leading up to that, I think it was finally time to update the document in March of 2020, last month. 4 years later, authorship from multiple companies this time, the major IWARP manufacturers, if you will, updated requirements and concepts, basically refreshing them up over the few years, and added a specific protocol proposal. Still to be written and sort of TBDs in the existing document, the ordering rules, the local interface, and local processing sort of round out the discussion. And to be discussed today is not to decide, but whether it's appropriate to adopt as an NFSV4 working group item. I'll tell you why. The RDDP work group, what formerly owned IWARP, is no longer active. It was closed down several years ago. So over the years, we've discussed candidates for future adoption of continued IWARP work. One is the TSVWG, the sort of catch-all transport area group. Unfortunately, that's a large catch-all group without a lot of specific RDMA focus or specific RDMA expertise. It tends to have quite a few areas represented. Second candidate was an independent proposal. We would just continue to publish it as an independent draft, and it would enter the independent RFC stream. It's certainly possible, but it's undesirable to update an existing IETF spec like the IWARP suite in this way. It's kind of strange, as a matter of fact. The third one that was proposed in the meantime was, let's just do it in NFSV4. It's a relevant area. It's in transport, it's storage related, et cetera. And there's a lot of RDMA expertise here. So it made a lot of sense to me and to others. I'm going to make a tentative recommendation that the NFSV4 workgroup adopt this. Let me just give you a little bit of motivation. First of all, there is significant NFSV4 workgroup activity in this area. RPC over RDMA is the obvious one. It's an existing effort. It's currently being extended as RPC RDMA v2. There's no actual interdependence between these two possible areas, but there's a strong relation between them. They're both RDMA, they're both data over RDMA, NFS or storage data over RDMA. Second, the PNFS NVMe over Fabric use, possibly including PCI Express peer-to-peer transfers. Soren and David Black gave that presentation earlier in this meeting. I was glad to see it. And third is, which I've just discovered, is the push mode layout that Christoph published back in 2017 is actually closely related to this new NVMe over Fabric.
By the way, I'm not referring to that, by the way, in the graph. We refer to.
So, you know, these are all related activity that have been in the NFSV4 working group over time. So, you know, there's RDMA expertise and there's RDMA development activity. There's strong storage relevance to a persistent memory equipped server. Many NFS servers are adopting persistent memory in their storage panoply. It's also relevant to remote shared memory models. That visibility feature that I mentioned on the beginning is strongly related to remote shared memory. That's not actually storage related, but it's closely related in terms of the fabric requirement. So there's current NFSV4 working group activity on this document. I CC'd the NFSV4 working group after publishing it last month. So there's been some informal discussion about this with, I must say, broad support. Comments have been received on the NFSV4 list. Thank you, Chuck. I've deferred response to those comments until this discussion. I thought it was premature to reply on an IETF mailing list to such a thing, but I am prepared to do so. I've also received a bunch of comments off list. So, you know, there's work pending here to republish that document. To make a final decision on whether the NFSV4 working group takes this on will require, obviously, consensus among the working group itself, some sort of proposed charter edition. That's probably just a sentence, but it's important. Working group chairs, area director, and other IETF processes all need to be in agreement on this. And we would update the draft instead of as an individual draft, but obviously as a draft NFSV4 or draft IETF NFSV4 retitled. I would propose something along the lines of the name RDMA placement extensions, which I think most accurately describes the extension. And that's my intro. So I'd welcome discussion.
Well, I think you've made a good case that this is worth taking on, but I think we have to schedule the, first of all, we have to figure out the consensus on this. How long, in your estimation, would it take, would be an adequate time to discuss this and come to consensus on this?
Well, among the people I've discussed it with to date, everybody has been strongly in favor. There were a couple of messages that went to the mailing list already on this. One from David Black, for instance. I'm just trying to remember who else chimed in, but there were a couple of public statements made in support of this idea. I haven't heard anybody say it's a bad idea. So I would expect it would be fairly easy to determine whether we have consensus.
Okay, let's say a week, or a week or
Well,
10 days, something like that.
I think
I'll
we
send
should
a
have time for everybody
message
to at
out.
least be aware that the question's being asked. But yeah, I would say
so maybe
during the month of May. It's certainly possible.
So this is Magnus. Yeah, I mean, I've been a bit. Is this work gonna bring in more people to work on this, or how do you prioritize it related to other already existing work group item or other proposals? I think that's something for the working group to consider, because
yeah, I can answer the first question. Will it bring in more people? I think the answer is yes. My co-authors in particular are all representative of companies that have IWARP products. There's one additional co-author who has agreed to jump into the next revision, who's also an IWARP developer. So I would expect them to join and the discussion, certainly. And I don't know who else might be lurking in the wings, but sure, there are other RDMA interested parties who previously may not have been participating in NFSV4, but would hopefully join the discussion.
Yeah, that's a very important point, because IWARP is popular maybe, but you know, there are others transport that are used, at least from my research for the other draft. So I'm not sure that focusing on IWARP will be a good idea.
Well, I mean, this draft is specifically an IWARP extension. I think it would be a good item for discussion in the NFSV4 working group if that scope should be expanded as part of the NFSV4 adoption.
Exactly, my point. That's my point. I mean, it should expand it. If it's only for IWARP, I don't know if everybody, many people would.
Well, the proposal, as I mentioned early on, the proposal in the InfiniBand Trade Association is almost the same semantic. I would expect the same verbs, for instance. The only difference is that currently omits verify, which I believe is highly important.
From my perspective, I definitely need to think about this, and also what to do with the charter, etc. I mean, I agree with your assessment that something needs to be done about the charter if it's going to be take this on. It's a bit far beyond what's the current NFSV charter allows, I think. And so.
Indeed.
Magnus.
Yeah.
Magnus, should we have the discussion that for Tom to open up the discussion while we noodle on whether we consume it?
I think it's fine for you. I mean, it's a thing. I don't see another venue where you easily can judge if there's interest, etc., and how much people who would be interested working on this, etc. And I think those are important aspects of this. But I am to say I mean, I want to see that we actually, how do we actually get to finishing up the most important work group items, etc., and all these other aspects also. So and how does important is this in relation to? But that's I think NFSV working group mailing list is fine to discuss this, but so.
Okay.
Okay.
But then Tom, so start the discussion, Tom, but realize we have to have a bigger discussion about whether we can consume it. Okay.
Yeah. I mean, these were the areas that I felt might consume it. So,
As a working group,
yeah. Okay.
as taking on the work, that's the only. I think that's what
I
Max.
see that the mechanics of actually taking on the
The actual hands whacking on something relative to other things.
Yeah.
Mechanics of it, the actual.
If we were to take on this one, you know, then I believe there would be immediate relevance to it.
Maybe, maybe not, because we are looking mostly at TCP transport. So.
Okay. So, I thought you mentioned that a flush extension would be needed for that.
Yeah,
but okay.
yeah, but
No, David Black said that's actually not relevant. I think taking this on would be relevant if we took on push mode. The third bullet here.
Right.
Yes. So we have this. We've attempted over a number of years to get this this layout done, and I think we need to figure out how to do that. It would certainly be nice.
Okay.
Just one point before you all hang up, I was not able to access the list, so maybe somebody will have to do the list after the call, because I tried to edit it as you mentioned, DP. I edited it, deleted, so I have no idea.
Everything's fine. There was one more thing on the agenda. Sorry, we're at 12:02. Potential work to enable new transports, Chuck Lever. It was 15 minutes. We're over.
I agree to drop that today.
Okay, didn't hear that. Thank you.
No, I just said that right now, so you didn't miss anything.
Okay, so we're dropping today. Okay. Hey, Magnus, is that okay? We're dropping an item to finish up. Can we take it to the list just to start churning it?
Yeah, I mean, so I mean, from my perspective, it's fine for you to discuss it, but I think you need to keep in mind, I taking on new work. I actually think you really need to think about how you prioritize and etc. And you still have a couple of work group items up open and ongoing, and I don't. So it's those aspects need to be thought about, and I think really it's not just gobble up more work, because that's not going to be endear you to me more, but rather the other opposite. So it's it's fine to discuss things while still on individual level and just interest and trying to understand how important is that this to happen, etc. But I think we need to work more about that kind of prioritization list of how do we get things done, etc.
Yes. Okay.
And another aspect of this is I think we need, or say I will talk to the chairs more later on, etc. But also for the working group is saying, looking at the situation, more regular. If you're gonna go to more regular virtual interim now, when not gonna be possible to meet that well for at least for a while, to keep up maybe pace here and resolve things. So think about that.
Okay. All right. If there's nothing, Dave, you have anything else?
No.
Okay. I had taken minutes in Etherpad. I'm going to produce a document and upload it to our doc site, the meeting minutes and stuff like that. If you guys take a look at it, and if there's anything in there I'm missing or I should add or correct, please do. I'm not really trusting Etherpad stuff, but it started working again for me. Anyway, okay, if there's nothing else, Dave, let's call the meeting.
Let's do. Any objections? None? Let's go.
Thank you, guys.
Okay, and I'll upload your slides, Soren. Okay,
Thank you very much.
guys.
Thank you.